Good morning, folks. This is Mr. Dan coming to you from the Landscape Design Classroom, and today I'm going to talk to you about essential nutrients and their roles. So, 16 nutrient plants require carbon, hydrogen, oxygen, down to non-minerals, and supply the plants from carbon dioxide, water through photosynthesis. So, 13 more nutrients, primary or macronutrients, secondary nutrients, and micronutrients. And we're going to jump into all these today. So the 13 nutrients grouped by the amount of plants, or the amount needed by plants. You have primary or macronutrients, which are nitrogen, phosphorus, and potassium. Second nutrients, which are calcium, magnesium, and sulfur. And your micronutrients, boron, copper, zinc, iron, manganese, molybdenum, and chlorine. So these 13 nutrients are all minerals except for nitrogen. The primary nutrient, nitrogen, its function is to promote rapid growth, chlorophyll formation, synthesis of amino acids and proteins. Deficiency, stunted growth, yellow lower leaves, spindly stalks, pale green color, and one of the Earth's most abundant and mobile nutrients. Nitrogen is widely used in the landscape industry. You have to be very careful with the amount you're putting on. If you use too much, like it says here, you'll end up yellowing the leaves and perhaps stunning growth. But if you use the right amount, you'll get your maximum growth possible. So always refer to your label and do your plant research before applying. The phosphorus, its function is to stimulate root growth, aid seed formation, used in photosynthesis and respiration. Its deficiency is purplish color in lower leaves and stems, dead spots on leaves and fruits. You have to be a little careful with identifying if there is a deficiency in phosphorus, though, because there are a lot of plants with a purplish red leaf to them. So yeah, you really have to know what to look for. Like I always say, just make sure you do your research before you go out and try to diagnose this. And it's very immobile in the soil. Potassium increases vigor, disease, resistance, stalk strength, and seed quality. When you're looking for a deficiency in this, it'd be a scorching or browning of the leaf margins or on lower leaves and create weak stalks. And much of a soil's potassium is tied up by other minerals. So calcium, constituent of cell walls, aids cell division, kind of like I compare it to all the milk commercials where they say, we'll make bones stronger by drinking milk because it contains calcium. So think of the same thing here. If there's a deficiency, it's a deformed or dead terminal leaves and pale green color. The magnesium, its function is a component of chlorophyll, enzymes, and vitamins. It aids nutrient uptake. And when you find a deficiency here, you're definitely going to have some yellowing from chlorosis of lower leaves. So don't always look at the top of the leaf. It's kind of like a theme in here. You want to take a look at the leaves under, because you're not getting as much sunlight to those leaves underneath. So you'll be able to better identify quickly what a plant might be missing. Sulfur, constituent of the amino acids cysteine, cysteine, and methionine, found in vitamins, enzymes, and coenzymes, gives green color, required for nodulation and nitrogen fixation in legumes. Its deficiency here is going to be yellow upper leaves, so it may have a stunted growth. Boron, it's important to flowering, fruiting, and cell division. And the deficiency here is terminal buds die, thick, brittle upper leaves with curling. Copper, component of enzymes, chlorophyll synthesis, and respiration. The deficiency here would be terminal buds and leaves die, start turning like a bluish green color. So on these last couple, make sure you're looking at the bud on the plant, because once you start seeing the buds on the plant turn a different color, it's much easier to identify than trying to look at the leaf structure at that point. So chlorine, It's not well defined what their function is. It aids in root and shoot growth. Deficiency here would be wilting and chlorotic leaves. Sometimes you may even find like a whitish tint on them. You can easily mistake that for a powdery mildew. So whenever you're looking at something with white on it, make sure you look up both chlorotic leaves and powdery mildew as your first go-tos. Iron, catalyst in chlorophyll formation, component of enzymes. And its deficiency here would be intervenal chlorosis of upper leaves. Manganese, chlorophyll synthesis. Deficiency here would be dark green leaf veins, intervenal chlorosis. So whenever you're looking at the leaf itself, don't look at just like the flat plane of it. Make sure you're looking at the veins going up through the leaf. If they're starting to look darker, then it's probably going to be intervenal chlorosis. Molybdenum aids nitrogen fixation in protein synthesis. And similar to nitrogen, if it's lacking in nitrogen or has too much nitrogen, you might start seeing like a yellow in the leaves. Or just basically a deficiency. But if you put too much nitrogen in, you are still going to see some yellowing because it can't take on that fast growth. Zinc, needed for oxidant and starch formation. The deficiency would turn into intervenal chlorosis of upper leaves. So you won't have to go under, you'll definitely see it from the upper leaf or the upper layer of your leaves. So nutrients can only be used by plants if they occur in the soil in available forms. Forms not available for plant use include insoluble chemical compounds, unweathered or undecomposed soil minerals or rock fragments, organic matter or plant residues, and nutrients trapped by soil particles. So major factors in availability, if the pH of the soil is unsuitable, the nutrients will form insoluble chemical compounds. Some nutrients interact, hindering or helping uptake of other nutrients. And organic matter in the soil ties up nitrogen while it decomposes. So if we take a look at our pH here, always remember that it's numbers 1 through 6. If you're below 7, you're going to be acidic. If you're above 7, you're going to be alkaline. And if you're right at 7, that's your neutral base. So various plants grow better with different pH levels. Whenever you're trying to grow plants, it's actually most of the time better to be slightly acidic, anywhere between that 5.5 to 6.5 range. Lime is added to raise pH. Elemental sulfur, iron, and aluminum sulfate may be used to lower soil pH. So soil testing, which we'll be doing in here. Many different nutrient deficiencies may have similar symptoms. Soil testing is the most accurate way to find pH and available nutrients, which we do a lot of pH testing in here utilizing the variety of soils that we have. Determines kind and amount of fertilizer needed. Fertilizers, only one primary nutrient and straight material. Each of the 3 primary nutrients is complete or mixed fertilizers. Dry or liquid form we use in this class, we'll definitely be working with dry forms of fertilizer. And label gives grade and percentage by weight. So an example of this would be a bag labeled 5, 10, 15. So that would include 5% nitrogen, 10% phosphorus, and 15% potassium. So we're going to get a little bit more into fertilizers and whatnot and soil additives here in the classroom through the greenhouse. But we'll be talking more about this entire subject while we're working hands-on here within the greenhouse or within the classroom. So if you have any questions at all, please contact me down here in the landscape design classroom, and have a great day, folks.